Hello and welcome to the next lecture, Lecture 6 of Global Climate Change. I hope you guys all did well on your test, your midterm. And if you haven't already taken it, I would suggest taking it before you watch this lecture because this material will not actually be on the test. So today we're basically just going to go through feedbacks. Feedbacks are a really important piece of global climate change, and it's a good thing to kind of quickly go over. The week that we have the test, it's a main concept, but it's not too long of a lecture. So let's get started. All right, so the Earth's climate is actually fairly stable in terms of its actual temperature. Okay, this can actually be visualized using the following system diagram. Okay, so basically what's happening is imagine this piece right here is like a rock, okay? And you push the rock up basically the hill. Well, if you push it up to this point, what's going to happen? Gravity will kick in and it'll basically come back down and rest in the same place that it began and the same place that it started at. Okay, so even though the system may change away from its initial point, much like you pushing it up the hill here, it would actually have the tendency to go back to normal eventually, much like this rock actually going back down to, the bottom where it first started. Okay, so given a force, the system tends to return to its initial state. That's the original state. That's basically what we're talking about. But instability is kind of the opposite. So if you give it a force, you know, that's the stable equilibrium. But, imagine if you start at the top of the hill and then you basically nudge it down to, down towards the bottom. It won't end up where it began. It began here. It's going to stop here. So unlike the stable equilibrium where if you push it up here, it'll go back down where it began. In an unstable situation, if you push it, basically it's going to end up in a different place than where it started. Okay, now there actually might be multiple states of this equilibrium. You may push it up to you may push it up here and it'll go back down and it might be stable. But if you push it up a little bit further up here, then it might actually go down to here, which is not where it began. So this would be unstable. So in this situation, it would depend actually on how far up this little hill you actually push this rock or wheel or whatever you want to call this here. So, much like that, our environment, or I'm sorry, our temperature and our atmosphere, you can nudge it or you can warm it a little bit in certain ways or cool it in others, and that's fine. It'll go back to where it started with to begin with. But if you do it too much in any one direction, then you risk, basically pushing it past that point where then it would be unstable and it would end up in a different place where it actually began. Okay, so that's kind of what I was talking about with the human-induced or anthropogenic forcing on climate. Remember, the anthropogenic actually means that this is human-induced, not natural. The more greenhouse gases that we put into our environment or the more emissions that we have, there's going to be stronger forcing, towards the warming end. And we can actually already start seeing the effects of this. We're seeing increased global average surface temperatures. We're seeing decreasing Arctic sea ice during the summer, and we're also seeing some rising sea levels. Earth and its atmosphere system will always try to reach a new equilibrium, regardless if we just push it a little bit and it goes back down to the beginning, or if it basically goes too far, then it's just going to find a new equilibrium. That equilibrium being the balance between the incoming and outgoing solar energy. I'm sorry, radiation. Okay, so right now we have a one balance going on, but if we push it too far in one direction, then we might see a new balance. And that would be where the surface would be at a higher temperature. Now, the Earth's climate changes as a result of internal and external forcing factors. We already went over these: the changes in solar radiation, the orbital variations, plate tectonics, volcanoes, and then we also have those greenhouse gas emissions. Now, each of these forces can be thought of as a push to climate stability. We're going to have changes in solar radiation kind of one way, and then, it's hopefully going to go back to where it began with and be stable in the end. And these forces can be enhanced or diminished by positive or negative feedbacks. Okay, so this is where we're starting to get into this feedback. So climate feedbacks, we have two types of them, okay? We have positive feedbacks and negative feedbacks. So positive feedback is after we have that initial change, that initial forcing, we have that reinforced by another process, and this leads to us being further away from, where we began. But the negative feedback is we're going to have that initial push, and then we're going to have it counteracted by some other process, okay? And that's going to help the system move back to where it began to. Okay, so an example of positive feedback, okay? So processes that actually accelerate a change. Now, the first thing I want to make sure I say is that feedbacks actually cannot initiate or begin the change. They can only alter the pace of change. So it can't start it, but once it's begun, then it can, the positive feedback can kick in and then keep making it go further. So an important climate example, there's actually a few of them. We have ice albedo feedback and then water vapor feedback. So what is ice albedo feedback? This is where, this is a cooling effect, okay? So basically somehow we're going to have some initiating mechanism, okay? Something that's going to cause, maybe a volcano will explode and it'll, put a bunch of ash into our atmosphere. It'll block the incoming solar radiation and it's going to cause, the Earth to cool. Okay, and because the Earth is cooling, it's going to cause the ice actually the ice coverage to increase, whether through snow or it's actually going to have more ice at the poles or over the ocean, something like that. And then that's going to lead to the albedo actually increasing. Well, the albedo increasing is going to cause more of that solar radiation to be reflected instead of absorbed. Okay, and then it's going to cause more cooling because of the reflection. So it's going to cool, okay, ice coverage is going to increase, it's going to cause, more reflection, which is going to cause it to cool even further. And then it'll cool even further, and then it'll cool even further. So that's actually one example of a positive feedback. Okay, and here's another one, which is actually warming, but it's also a positive feedback. So say the Earth actually is going to warm. Okay, like on the other side of things, then that means that the ice coverage is going to decrease. Okay, and then that means that the albedo will decrease, and then that means that the absorption of sunlight will actually increase, and then it'll warm. Okay, and then that'll keep it warming, and then the ice coverage will decrease, and the albedo will decrease, and then the absorption will increase, and then it'll warm even more, and it'll just keep warming and warming. And so that's going to be, another example of positive feedback. Okay, so once we have warming happen and that sea ice actually is going to, be reduced, then we're going to have less of that being reflected, which will actually cause more melting to happen. And so that in that manner, it's actually a positive feedback. And you can see, I think I've shown you this graph already before, that is definitely melting, and the Arctic sea ice, the extent has actually been on a decline, for a while. This graph is from 1978 to 2013. Now, one of the things that this sea ice, decline is affecting is the polar bears. Now, polar bears actually exclusively pretty much eat seals, okay? And their only access to those seals is through sea ice. And the summer sea ice period has actually began to lengthen, which means that the summer sea ice has actually started declining. So the period in which is melting is happening more frequently and is happening longer. And these longer ice seasons have actually resulted in reduced survival of polar bears. So polar bears, they've noticed more cannibalism, more of them starving to death. I don't know if any of you guys have seen some of them that just look like they're, emaciated. That's basically because they can't get to their food source because there's not enough of sea ice. Okay, so now we're going to go into water vapor feedback warming. So this is water vapor instead of sea ice. First we have that initiating mechanism that's actually going to, start it. Like I said, it can't, feedback systems can't actually initiate change. It can only, cause it to keep going. So, something's going to initiate this Earth warming. And because the Earth is warming, then evaporation over the oceans is actually going to start increasing. Well, once the evaporation over the oceans start increasing, then obviously there's going to be a lot more water vapor in our atmosphere. Well, water vapor is a greenhouse gas, right? Well, that greenhouse gas is going to cause a strengthened greenhouse effect, which is going to cause further warming. Well, and the further warming is going to cause more evaporation. So, in that manner, it just kind of keeps going. And that's another example of positive feedback in the warming direction. Now, we can also have water vapor feedback in the cooling direction as well, because once we have the initiating mechanism, where the earth is going to cool, then we, on the other hand, can have, evaporation to decrease, which would cause less water vapor actually in the atmosphere, which will weaken the greenhouse effect, okay, which is going to cause more cooling. And in that manner, it just kind of keeps getting colder and colder and colder. It's another example of a positive feedback, but on the cooling end. Okay, so now we went through the positive feedbacks, we're going to go through the negative feedbacks. Negative feedbacks are processes that reduce and impose change. So once we have that initiating mechanism, it's actually going to reduce its effect. And it helps that system move back to where it started from. So we have a couple of those as well. Important examples would be cloud feedback and also plant growth feedback. Okay, now again, positive negative feedbacks have no relation to good versus bad, but are about how a system responds to a change. So don't think about a positive feedback as being good, because we both went through a cooling and warming, and too much in any one direction would be bad. It's both or neither, actually. All right, so cloud, possible role of cloud in warming or cooling in the atmosphere. First we have that increased warming by trace gases, including water vapor, which is going to increase our air temperatures due to the greenhouse effect, which is going to increase the water vapor, which is going to increase the cloud amount, okay? Well, once we get to that point, okay, the cloud amount is going to it will both increase the reflection of solar radiation, during the day, but at night it's going to increase the trapping of terrestrial radiation. So the increased reflection of solar radiation would have a cooling effect, okay, and the trapping of terrestrial radiation would have a warming effect. Okay, so we're going to have a net warming or cooling, depending on which one actually is stronger during the day or during the night, or what else is going actually on. So on which side, the left or the right, which one of these would be positive? So which one of these actually would cause it to keep going? That's going to actually be on the right. Okay, because you started off with it, getting warmer, and that's the initiating change. And then the increased trapping of terrestrial radiation is going to cause further warming. So when it keeps moving in the same direction, then that's going to be a positive change. Okay, and then another thing that is in the textbook. So I know a lot of people like to use as an example when they're teaching this. Is actually like a bed that has one of those heating blankets, and she has basically a thermometer or a thermos, whatever you call that, a dial on one side here, and he has one on the other side. Okay, so basically what's going to happen is this guy's going to get hot. So this guy's going to get hot. So he's going to turn his, thermostat down here. Okay, well, it's attached to his side of the bed, so he gets cooler, and everything is great. All right? Well, on the other side, say we flip these by accident. Okay? Well, he gets, really hot, okay? So he turns down his thermostat. Well, what he's actually doing is turning it down on her end. So she's getting cold. So what does she do? She actually turns it up because she's cold. Well, hers is attached to his side. So then he turns his down. So on that manner, it just kind of keeps going in this cycle where he keeps getting hotter and she keeps getting colder. Which situation on that would be a positive feedback? This one actually would be on the right side. Okay, because he's getting, he was hot and he did something to try to counteract that, and the thing that he counteracted made him warmer in the end, and then it just kept making him warmer. It went further in that same direction. Okay, so the last one here is, as a result of the Earth's warming over the past 100 years, plants have been growing at a faster rate. But because plants absorb CO2, the increase in plant growth means that more CO2 is being absorbed by the atmosphere, from the atmosphere by plants. All right, so the plants will get bigger, okay, because of the warming. So the initial thing, okay, is going to be the warming. And then the plants are going to grow because of that warming, but then they're going to absorb CO2. Well, what is CO2? That's a greenhouse gas. Okay, so that absorption of the CO2 is actually going to cause it to get cooler and not warmer. So this actually is a negative feedback because the initiating event, caused it to go in one direction, but then through these feedbacks, it goes back to the same direction that was back in the other direction towards where it started from. Okay, that would be the negative feedback. So that's going to be number 2. All right, so I have basically one, I think it's just a couple questions for homework just to make sure that you understand the concepts of feedbacks, and that's it for the week. I know that you guys had a test, and so I didn't want to, overload you too much. So I hope you have a great week, and I'll see you next week. Bye.